Okay, I'm recording now. Okay. All right, this is actually lecture 4 of our Ollie series, Energy and Economics. I'm Charles Hall, and we're going to talk about the Industrial Revolution and a few things that led up to that. And today's, we're going to talk about exploration and colonization. And this is going to lead us to a good energy lecture on how the Earth works as a heat engine, the impacts of colonization, formation of fossil fuels, the exploitation of fossil fuels, coal in the Industrial Revolution, then oil, and the origin of the modern oil industry, which I bet you didn't know was Ontario. Okay, so our summary so far about humans and their relation to energy has focused on the evolution of humans physically and especially culturally, and how they used energy in the past, including some ways that we may not think in terms of energy. And fire was important because it allowed us to cook food and allowed us, therefore, to eat a lot more plants. And plants are hard for many organisms to digest because plants have cell walls. Animals do not have cell walls. And so if many ruminants, cows and the like, have very complicated stomachs.
His birthday is 2/20.
Terry, could you shut off your recording, please? Your mic. Cows, for example, have to process their food with 4 stomachs and lots of bacteria over a lot of period of time. So if you're eating mostly plant foods, it's a pretty tough situation. And so the evolution of fire use was really important as an energy source, expanding the food for humans. Many tools, spears, knives, and axes, are actually energy or force concentrating devices. We talked about the ability to puncture the skin of a tough animal, a tough skin of a maybe tough animal. And you can do that if you concentrate the force in a small area. And that's what you're doing every time you cut something with a knife, or cut a tree with an axe, if any of you are doing that anymore. You're taking your force and concentrating it on a small area that then allows you to do a whole lot more work. Now, humans, of course, had an increasing ability to exploit resources over time that very few other animals or plants had that. They could only do it through genetic changes. And usually genetic changes meant if you could do one thing, for example, have greater burst speed, it was at the expense of something else. And just to give you an example, I was watching something on the news about marathons the other night, and most of the people that win marathons now are from Kenya, and even a very small area of Kenya, of East Africa. And I had once read an article about them saying that if you look at their shape of their legs, they have very thin lower legs. The muscles on their lower legs are actually quite small. And this allows them to run their legs back and forth for a long time and very efficiently. Now, these people are from East Africa, where it's open savanna. And this is purely speculative, but most of our fastest sprinters are from West Africa origin. I mean, either directly from Ghana or some area like that, or from their ancestors in some time in the past were from there. And they have big, thick, muscular thighs, I'm sorry, lower legs, calves, completely different shaped than the people who run marathons. And they don't know, but one can imagine that living in a more heavily forested environment, sprinting was more important than the long distance running that we talked about from presumably our ancestors in East Africa. So certainly every little piece of who we are had to do with the environment in which we evolved and the circumstances that we faced in the past. I don't know if that's a good example, but it, since we think a lot about who are the fastest humans, that's at least an interesting hypothesis as to what might be going on. Now, the evolution of agriculture, of course, was enormously important. We'll talk about that a little bit more today. And when you had energy surplus, it did not necessarily translate, except immediately, into a better life. It usually translated into more humans and more environmental impacts, and sometimes you didn't win at all, and simply because more of one's offspring survived, and there became more and more humans. But we'll take a look at that over long periods of times. And of course, humans expanded into originally into Europe and Asia, and then North America. Okay, so Leslie White was the first to say this, that human cultural evolution is about increasing energy surpluses. And Leslie White was a great sociologist, anthropologist, and his colleagues who were more interested in culture and not so much interested in the physical sciences tended to belittle what Leslie White said, which is, I think, unfortunate because, incidentally, he was spelled without an L in the name. So some people thought what he said was wonderful, and some people said he didn't give enough credit to human cultural evolution. So in my view, this is a never-ending discussion of which I remain in maybe the center of, to some degree, and of social sciences versus natural sciences. And we'll see how that plays out when we talk about economics in later lectures. Okay, so agriculture spread from the off this map to the east from the Fertile Crescent, increasingly into Europe, and this just shows a lot of settlements where the red dots are, where they've taken a look at it, and how they study this is by the pollen. So where you have open nettles and grasses, it tends to be a more open environment, which implies in Europe, European influence. And the elms, pine, alders, and birch were presumably there before the land was cleared. I don't think it's a horrific slam dunk case, but that's at least claimed by the people who study this as the means of being able to tell when the human agriculture went through at various times. I don't see barley, for example, on that data set. But anyway, certainly agriculture spread, and this is an area before fertilizers. This is a famous painting by, let me see, Bruegel, Bruegel, and boy, it's a really very productive looking barley or wheat, whatever it is. And you can see the people are taking a lunch break, and one guy's zonked out, and they're cutting bread in the foreground that is presumably made with this barley or this wheat. I can't figure out what's in this is. It looks like somebody hiding. No, but they're cutting by hand, and you can see this is a very labor intensive process, and looks like there's a couple of partridges here, and there's a big wagon going to town with lots and lots of harvest. So this certainly looks like a very agriculturally productive situation. And here's another picture I have of made many hundreds of years ago of people undertaking very labor intensive agricultural processes. So you can see actually that most of human time, except for this noble who has a hawk and is hunting, most human time was very laboriously involved in dealing with agricultural issues. And so we would say that humans, the energy return on investments for humans was probably modest. We don't know, but I will give you an indication shortly of how we can figure that out in ancient times. But the problem with agriculture, it would wear out the soil. It's especially understood in England and Germany. And England, even they were so concerned about in 1800 or so, they were so concerned about the diminution of production in English fields that they passed laws requiring them to have more animals so they could get more manure. And also they would go to the battlefield of Waterloo. I guess that was a little later than 1800, and they would dig up the bones of the French soldiers and their horses and grind them up to get phosphorus and calcium, and I don't know what else was there to fertilize the tired English fields. So this was understood in a general sort of way. And then along came a guy named Justus Liebig, and this is something we learned in our first course in ecology, in Liebig's law of the minimum, that the element, the chemical element, and sometimes another factor, but a chemical element that's there least relative to the demands of the organism. And this turned out to be generally nitrogen, phosphorus, and potassium. So if these are in a ratio of nitrogen to phosphorus, about 16 or 18 to 1. So if you have 12 atoms of nitrogen to 1 of phosphorus, nitrogen is limiting because a plant needs at least around 16. So even though you need more nitrogen, you have to get the ratio right. And once people began to understand this and began to understand the nutrients in the soil, they were able to be much more efficient with their fertilizers because they could put on only the one that was limiting. The problem was there wasn't a lot of nitrogen available in general. All of South America, for example, is limited in phosphorus. Potassium is a bit more common around the world and can be gained, for example, from potash from chalk or the embers left from fires, the residues of fires. But the first thing that Europe did was they found that guano, bird shit, from islands, especially off of Peru, were very rich in nitrogen and phosphorus because of millennia of birds concentrating the nutrients from the fish they ate and depositing them on the soil. And so they started bringing in nitrogen from islands in the Pacific, and it was worthwhile bringing ships full all the way around the tip of South America and back to England to bring in the nitrogen. This nitrogen was also the basis of gunpowder. Gunpowder has actually less energy in it. A gram of gunpowder has only 1/5 the energy of a gram of sugar. But what makes it gunpowder, what makes it explosive, is that it has a reduced component, that is ammonia, and an oxidized component, that is nitrate. ATE on a word means oxygen containing, right next to each other. And if you give them a shock, they'll combine instantly with great force. And that's the basis of of gunpowder, and still is today. Nitro Express works because it has ammonia and nitrate right next to each other in the molecular structure, which can combine very quickly and explosively. So both gunpowder and fertilizer are nitrogen-based. In the Civil War, then good Confederate ladies would save their urine and dry it. And that was used by Confederates to make their gunpowder. It's quite a story if you really dig into it. Okay, now there became, I'm skipping back a little bit in time, the time of exploration and colonization. People stayed pretty much where they'd been for 1,000 years or thousands of years until exploration began, and originally on land from Italy, Marco Polo going to China and seeing all this amazing stuff, a much more highly developed culture in many ways than Europe. And Marco Polo talked about all our wonderful things, except that they did one terrible thing, which was they took their feces and put it into their agricultural soils, which he thought was despicable. Meanwhile, of course, Italians and Europeans were taking their feces and putting it into the drinking water. So there's some irony there if anybody's into public health. Now, Jared Diamond wrote a very influential and interesting book called Guns, Germs, and Steel, where he said an important thing is axis, AXIS, where species, and we talked about oxen and donkeys and so forth, could spread easily east and west in Eurasia because they could go, and because the temperature was relatively the same, and plants and animals could be brought back and forth. And certainly all kinds of plants and animals came from the original Fertile Crescent to Europe and to Asia, although Asia continued to be focused mostly on rice and Eurasia on barley and wheat. But anyway, this is the idea that it was a lot easier to move east and west. And there were lots of plants and lots of animals and lots of diseases and lots of people that moved east and west, including with various invasions, such as by Genghis Khan and so forth. So all people originally came out of Africa, presumably East Africa, spread around the world, and pretty much stayed put for 50,000 years, and then they started to move with Marco Polo, and I'm sure my rendition here is Eurocentric because that's what we have the most information about. Native Americans crossed into what's now Alaska when they could do it when the sea level was lower because the ocean water was tied up in ice age. So there was a lot more continental shelf at the time, and it was very easy for people from Asia to move into North America, and then all the way down to Tierra del Fuego, all the way throughout the Americas. Now, don't forget that the Danes and originally came to Iceland, to Greenland, and to North America, and left some signs, but they did not colonize. And so they pretty much went back and stayed back where they were. Okay, now what became really important in the mass migration of Europeans was Henry the Navigator from Portugal. And he created a tool for navigation where many people, including, I think, Columbus, I'm not quite sure, learned the tricks of their trade. He never actually went on a voyage of exploration. That's not quite true. He went down the coast of Africa at one point, but he sponsored expeditions that went all the way down the western coast of Africa. And let's see, we'll take a look. And so from Portugal, these Portuguese explorers got to the Azores, and they began to go down the coast to the Cape Verde Islands and so forth. And this was a very, very difficult voyage because the winds, as I'll show you later, were blowing from the east to the west, and they had to tack into the wind to get around Africa. Now, when they got to Africa and they could get all the way over to India, it would be a very, very profitable voyage for them. And I had a good friend and colleague, David Pimentel. Maybe some of you have read some of his really good work. But he told me once that he was originally his family was Portuguese, and Pimentel meant pepper. So he assumed that his ancestors were involved in the spice trade, either getting the spices or selling them back in Europe. And so that people began to understand that by doing trade from other parts of the world, you could make a great deal of money. I understand that pepper and other such spices were really important before refrigeration, because very often your meat would be rotting, and you could use the spices to cover the bad smells and tastes of what we were doing. But for whatever reason, a ship full of pepper or other spices could make an enormous amount of money in the time. Now, what Portuguese figured out was the way to get around Africa was not to go into the wind and down along the coast, but to sail way out in the ocean, to go on a reach instead of attack. And then when you got far enough south, you'd hit the westerlies, and we'll talk about this. And you could get around Africa so much shorter, in so much shorter time. And so this began with Columbus, of course, and very soon many other people this war, this well, it was this war, this period of exploration with conquistadors or conquerors, all of course blessed by priests and so forth and so on. So the slaughter of present day people so that their souls could be saved. You can figure that one out if you want. I have no capacity to. And but they had a lot of problems in getting from Europe to the Americas. Now, one thing you should see is that where we are at 40 degrees or so is more or less at Rome. Europe is much warmer. So if you went from relatively warm or temperate England to the Americas, you'd be in Labrador. You'd be too cold to grow anything and to live much. I mean, unless you're an Eskimo, of course you can, but just fine. But and it was very hard to travel over to America. Now, just as an example, the Mayflower, this is the replica, and this is very near where I grew up. So I grew up inculcated in all this stuff. The Mayflower took 10 weeks to sail from England to Massachusetts. 10 miserable cold weeks. But it only took 3 weeks to sail back. And that's because of the prevailing westerlies, which also are the winds that bring us relatively temperate temperatures from the Pacific Ocean. So how does that work? So I'm going to take an excursion, an energy-based excursion, into how the Earth as a heat engine worked. So the currents, incidentally, the winds blow the currents from the warm area of the Caribbean, more or less, up towards Europe. And that's why Europe is so much warmer at a given latitude. And this, of course, is called the Gulf Stream. And eventually, the Spanish, Portuguese, and so forth would learn to go this way to the Americas, sail south to the Americas, and come back relatively northward. So they'd bring European goods to trade to the West Indies, pick up slaves, bring them either to North America, and then get another product in cotton or something and bring it up to Europe. So these very complicated sailing routes were all based on these wind and water patterns that allowed captains to sail their boats much more efficiently. Now, the guy who figured it out was this handsome dude, George Hadley. And he lived between 1685 and 1768, and he was an English lawyer and amateur meteorologist. Interesting, a lawyer figured this out. And the key is he understood that Earth was a giant heat engine. And we talked just very briefly about this earlier, but the photon flux density is highest on the equator. So you can see that yourself. You go out in the middle of a clear sunny day and hold your hand perpendicular to the sun, and your palm will not heat at all. Let's see if I can do it like, let's say the sun is that way. And then you move your hand progressively until it's perpendicular to the sun's rays, or more technically, the photon flux of the sun, and you'll feel your hand warm up. And then you go back like this and your hand will cool down. So the density that the photons are intercepted on an area of land determines how warm that land will get. And so here at the equator, where on average, the heat flux is largest, the air warms up and it rises and you get clouds, and you look at where the equator is. And incidentally, we have to talk now about the thermal equator, which means the part of the earth that at that time of year between the Tropic of Capricorn and the Tropic of Cancer, Tropic of Cancer to the north, Tropic of Capricorn to the south. That's the extent that the sun is directly overhead relative to the earth, 23.5 degrees north and 23.5 degrees south. In that period, the sun will be overhead for at least 1 hour a year. And so this whole machine of the warmest air rising at that point, because warm air rises amongst cooler air, and that brings air masses upward. And as they go away from the surface, they cool because there's less less thermal energy supplied from the photons striking the earth. And they create a high pressure area above the equator that pushes the air masses north and south till they cool enough to fall towards the earth. And this they do at 30 degrees north and 30 degrees south. So what you have is the sun driving this engine of moving air masses around and greatly influencing the distribution of water. So on the equator, you get tropical rainforests where it rains every month of the year. Sun passes over twice. And then the sun goes up to about just south of Florida, and the whole process will move northward and southward. So in summertime, June 21st, this whole process is taking place just south of Florida, Mexico City, and so forth. And then in the winter, the whole process is taking place down in the very north of Argentina. Okay, now it's not quite that simple, because these Hadley cells, which are very powerful, drive a secondary cell called a Ferrel cell. I don't know who Ferrel was. And then a third cell that are called Easterlies after Mr. Easterly. I don't think so. But anyway, and what that means is on the Earth's surface, the air is moving from 30 degrees north, which is a high pressure area because the air is descending there and piling up, pushing the air towards the equator. And then as such, these air masses are going from 30 north to the equator, but there's another trick, and it's the Coriolis effect. So the Coriolis effect means that the Earth is spinning into the winds. The equator has to go 25,000 miles in a day. The 30 degrees has to go something like 18,000 miles a day. So the equatorial areas are spinning into the wind that maintains the mass, maintains the momentum from 30 degrees north. The Earth is spinning into that wind, and that generates the trade winds. They're called trade winds because that was the Spanish and Portuguese found out the winds that were most favorable for trade. Now, the Ferrel cell going in the other direction generates westerlies. So a slower Earth is spinning into faster air from 30 degrees, and that's why our wind here in Oregon comes from the west. In the east, you get the same thing to a smaller degree. It's a little bit more funnel systems as the further you go north, but that's basically how we get the most important wind patterns and moisture patterns on the Earth, because of the Hadley cells and the secondary cells that they run. And I think the whole thing is quite fascinating. So, and it was very important to humans. Well, it's very important to humans today, and the distribution of vegetation. That's why there's a big, thick rainforest in the coast of Oregon, and then it gets progressively drier as you go east. The air masses are forced to rise up over the mountains and get colder and drop their moisture, and they come down the other side. They're relatively dry, and they pick up moisture from the land, and that's why we have deserts in eastern Oregon. Okay, so here again are the main patterns looked at from the whole world. And here we are about here. Okay, now with this movement of Europeans into an area already highly occupied by Asians or Native Americans, whatever you wish, you had a clash of cultures, and we know all of that story. And from the perspective of Jared Diamond and Guns, Germs, and Steel, well, the Native Americans are still trying to get their lands back. And this is a very contentious issue even today, locally in California and Oregon. But it was a very complicated thing. And you got to remember that for at least 3 centuries, the Native Americans basically dominated North America after the Europeans got here. You have to look at history from the perspective of different points in time. But clearly this was a clash of cultures, and there were just, in my opinion, terrible things done to Native Americans who were ecologically very well adapted to the environment in which they'd been living for thousands of years. And they did not have settlements. Some did, some didn't, but they tended to be nomadic and a nomadic lifestyle, and they lived probably quite well by probably much better than Europeans at the time, probably ate better anyway. And every European who was captured and raised by Native Americans, Thomas Jefferson wrote about this and other people did, wished to return to the native cultures. Every European and every Native American who was raised by Europeans wished to return also to the native cultures. So there's at least some evidence that that lifestyle was more fun or preferable or whatever, more amenable to humans. But Guns, Germs, and Steel, mostly the native folks were not immune to the diseases that the Europeans had been exposed to for a long time, where natural selection had selected for individuals that happened to have defenses against smallpox and other common diseases. So it was a lot of human misery was occasioned by the clash of cultures, and still the case, of course. In Central Mexico, for example, the number of people declined dramatically. From around 17 million, that's a guess, to a million. And likewise in this continent. The forests were cleared as an energy source. And a wonderful book is Perlin's Forest Journey, in which he indicates how important wood was in our past, charcoal and wood for regular heating. In fact, this year I heated my house with wood and cut it myself. every year of my adult life except one. So, and I understand now in Germany with the price of oil and gas going way up because of the conflicts and so forth, they're starting to burn a lot more wood in Germany too. So it's been a reliable fuel for humans for a long time. Of course, now there's a lot of emphasis to try to get the forest back to store carbon. And because once you cut the forest, you start depleting the soil and leading on. Here's the same place in Indiana, show the transformation of the landscape. We may drive through the Midwest now and think of it as all fields, but it was originally heavily wooded, often with oak trees. And there's any number of great literature, American literature about quote unquote taming the wilderness and so forth. Okay, now we're going to talk about the Industrial Revolution, and here are a few pictures just indicating how coal mines operated. So there's a hole that goes up to the surface, and a basket is being lowered, and all these men seen here are picking coal out of the ground, leaving pillars so that the roof did not collapse upon them, except when it did. Horses were underground with carts to carry the coal from one place to another. And it was quite a scene, I would think. Children were often used in narrow spaces, and women were sometimes coal miners. So I don't know if they did that by choice or were forced to do it or what, but anyway, lots of people were involved in digging coal out of the ground, and it was fueled by Watt's steam engine. Now, the original steam engine was Newcomen, and it worked this way. You burn coal, make steam, and with a valve, this little green thing, let the steam into the piston and push the piston up, which lowered a bucket or of some sort down into the mine. And then you shut this valve and open the red valve, which let in cool air, which would condense the steam, and atmospheric pressure would push the piston down. This saved England's coal mines, which were flooding. I even read something this morning in doing a little research for all this, that water is now flooding in England's coal mine is at 59 degrees Fahrenheit, is warm enough to heat houses. So there's some people are pumping water out of the old coal mines and running it into factories or storage places, and using that relatively warm water to heat the spaces. Okay, now James Watt met every Thursday with a series of other very clever English, Scottish guys, and they were guys, I guess, including Wilkinson. Now you can still get a Wilkinson razor. And Wilkinson was one of the first guys, along with Darby, to figure out making iron. And James Watt originally could not get steam engine to work, his steam engine, to work because he couldn't make cylinders round enough. He couldn't buy cylinders round enough. And so it was Wilkinson who met, and this was all part of what was called the Enlightenment. And the Enlightenment was an English and Scottish, maybe Scottish especially, and also French movement of sort of overpowering the old horrific structure of society that was very conservative and very much based on the church, originally the Catholic Church and then the English Church, and the old aristocracy and the old landowners and all of that stuff. So this idea of the Enlightenment was that we could use science and the scientific method to find things out. For example, whether the sun went around the earth or the earth went around the sun, or how to do something. Now, the trick Watt's engine is that he had push rods that were, I can't quite figure it out from this diagram, so I'm going to found a better one. But there's two tricks here. One is this device here, which I'll show you a better example of, that allowed the steam to be used on both sides of the piston. And the other was this governor, which could let the device run at a given speed. Okay, so here is a picture. It's no longer automatic, but there's a slider that's driven by the machine itself that moves the steam coming in from the top, either to this side of the piston, or when the piston is over at the other side, the slider goes back and the steam will come to this side of the piston, and the exhaust, the blue, will likewise go out from first this side and that side. And that was the trick, the Watt steam engine, and it was amazing. And so here's an original Watt steam engine, cast in stone, I guess. I don't know quite how it works, but this rocker then would run the device that would move the steam in one end and then the other end of the pump. And these were big things. And then people came along and attached with these overhead pulleys to straps to run looms. And these were very dangerous. It took them a long time to figure out just to put a simple metal cover over the belts, because people's arms and legs got caught in the belts or the gears. They were just horribly, look at these dresses right next to these spinning gears. These were terribly dangerous things. And of course, this drove demand for cotton. And so the British, the invention of the steam engine led to a great expansion of American slavery, and then to transportation. It's an early steam engine. Horrific health and social conditions in the industrialized areas. That's supposedly quite a good book. I haven't read it. And you see this coal undermining much of England. And this leads us to William Stanley Jevons, who was an amazing guy. And he wrote a book in 1866 called The Coal Question, an inquiry concerning the progress of the nation and the probable exhaustion of our coal mines. And this will play into our next lecture very much. And he began to plot things and notice what exponential growth. And this exponential growth, he figured would happen here is coal. That the black is what he knew. But if it continued to grow, he projected that the English coal mines would last no more than 200 years. And this was an astonishing thing. So the relation of an exponentially increasing use with a exponential, if you don't know what that means, it means it doubles every X number of years. So it goes from 2, 4, 8, 16, and so forth. Not linear, but it will grow exponential, curved. I don't know how to do it on my camera here. And in fact, this is a graph of English wheat production. So he said it's going to be in 1856. He said it was going to last 200 years. So that'd be 2000. So he was a little bit shy. It didn't last quite 200 years. I suppose it's still there, but it was a pretty good projection. And then he also came up with Jevons paradox. He said, therefore, we must make our engines more efficient. But then his supporters, the financial supporters from the crown, said, go back and think about this some more. And so he found that people had suggested, not as completely as he did, but had suggested we needed to make our engines more efficient. The Savory one was very inefficient because you had to keep heating and cooling the engine to make it work. And when they made steam engines more efficient, they became cheaper. And so people found more uses for them and the fuel consumption increased. This is Jevons paradox. Making machines more efficient does not save resources, and we see it again and again and again. So as we make our refrigerators more efficient, we make them bigger. And as we make our whole households more efficient at using energy, they become bigger. And this is Jevons paradox, and it is with us today. And that's one reason technology, it's very difficult to get technology to resolve our resource issues, which we will talk a lot more about. Okay, talk about oil. Here's petroleum production in just a few minutes. You have periods in the past, not very many, 100 and 150, 90 and 150 million years ago, where you had very great climate warming, global warming, lots and lots of algae, and the important thing was a lot of water bodies would stratify. If you dive down in the lake, you understand how the lakes, when the water is warm, you get a warm surface that doesn't mix with the colder, deeper layer. And when that happens, you get an anaerobic, and that's the key, anaerobic bottom water. And so the organic material, the plants and little animals, accumulate in the bottom. And this especially works where you have a rift occurring, as we have happening in East Africa now, but happened when Norway and Scotland separated and formed a rift. This is where the North Sea oil came from. And then all the organic material is down and buried in the bottom, and the rifts, and you have to have rains that fill in the rifts with sediments. And when you have these situations, then you form fossil fuels. And we're talking about oil and gas now. And so here's a water well up here. The oil and gas wells are much deeper. The oil tends to migrate because it's lighter than the rocks, and it's lighter than water. So it tends to go up until it runs into a trap. This is an anticline or a salt dome, or there are other traps that trap this oil. Probably 99% of all the oil ever formed has gone off into the atmosphere. The 1% that is captured in an oil field, you'll have water, oil, and then gas. And what you want to do is put your oil well down into the oil part, and the gas then will push the oil out. Now, as time goes on, you take out the oil, the pressure declines and you have to pump more and so forth. But this is basically how it works, and somewhere around 100 degrees centigrade is the perfect temperature to make oil. So the first oil well was not in Pennsylvania. The first modern oil well, the Chinese did it 4,000 years ago, but in not Pennsylvania, but in Ontario. And I had a friend that I met at one of the meetings who owned was a descendant of this guy back in the 1800s. And I actually have used this device. It's still there. He's on a platform. And you see the chain goes down to a drill head. And you jump up and down on this board, as I did. And you drill down, you punch down through the earth. And they did that in Ontario. And those oil fields are still producing. You'd make a tower sometimes with, you can see these old pictures. And this formed in 1861 before Colonel Drake was Fairbank Oil. This is in Western Ontario. And he made a lot of money, built a mansion out of this early oil field. And you see it was quite an industry at one time. And this guy, Charlie Fairbank, was my friend. And here he is. And he's got various oil. You can see some pump jacks, grasshoppers, some very primitive ones back here. He's on one right here. And his hobby is making memories of the old oil fields out of iron. You see, and he's got links of iron that go from a central electric motor that run these pump jacks up and down. And you can go and you can look at the pipe coming out and you'll see a little dribble of oil coming out. Well, it's not very much oil, but it's been doing it for a couple of 100 years. And it certainly makes a lot of money for enough for a comfortable life for my friend Charlie. And I'm sure he'd welcome you if you ever go visit Fairbank Oil. And here's another one of his metal guys that he's got commemorating his ancestors. Okay, pattern of use over time. You get enormously more energy as we develop more and more potent devices. And our economy, which is the dotted line, goes up with gray, coal, orange, oil, green, gas, and still a very little bit of other sources of energy, hydro fairly important. Over time, I'm born here in 1943. So there's been about an 8-fold increase in the use of energy in my lifetime. And I think that's pretty amazing. And this is true for Africa, although it started later, and Asia. There's another picture of Asia. Just to show you what this means, this is the 30 horsepower thresher harvester. And it takes 5 workers plus the stable boys, and then you got to grow the fuel for the horses and so forth. So that's 33 horsepower. And this is 200 horsepower. That has given us an enormous ability to do things, to do economic things. And nobody gives industrialization enough credit for what it has meant for our economy. In the past, very few people could be wealthy. This guy would be dependent upon the labor of thousands of others who would live in poverty. But it changed. The basis of wealth changed from land to factories. You can read it into Jane Austen's and others' novels. Supposedly wealth came from land owning because it was the land that was intercepting the energy, which was the sun. But when we started using fossil energy, it changed. Here's GDP per capita corrected for inflation. The average Englishman became enormously richer. That's corrected for inflation. And looking at it from the perspective of energy return on investment, which we'll talk about next time, from 1300 until 1750, about 2/3 this is for some reasons is an underestimate. Half to 2/3 of all the energy, of all the economic activity was used to get energy to run society. And then when coal came along, it dropped to about 25%, and then about 5% now. In other words, about half of all the economy that was operating was used to get energy to run the other half, you might say. And then with the coal revolution, it was 25% into 5% now. And as a consequence, we got enormously wealthy. Now, of course, we have very complicated ways for getting oil. The population grew. And a lot of our understanding of how energy runs our economies came from Howard Odum. And here's a natural ecosystem. And this is the flow of energy from sun to the various kinds of plants, to the herbivores, to the carnivores, to the crop carnivores. And with only about a 10% transfer from each food or trophic level to the next. So there's precious little to support things at the top. And you can think of early person living in the forest with all these different plants indicated by the first bullet-shaped symbols, and animals, and humans harvesting only a small part. But with agriculture, humans could get much more. See, this here, a natural person gets only about 0.4 kilocalories per square meter per year. But for an agricultural system, you can get 200 or so. In other words, 100 times or several hundred times more energy per square meter. And then you industrialize and it goes up from there. So this is just a view I like of an early town with crops and supplying the people living in a small community who might keep some herds and catch some fish, to a modern one, still needing crops and herds and fish from the sea, but all of which is running by fossil fuel, which allows a much greater concentration of humans because we greatly increase the flow of food to the humans. And I like this. This is a natural city, an oyster reef, that's subsidized by the tides. It brings in the food in plant cells to the city of oysters, clams, and so forth. And that's like a modern city where the air currents disperse, like the tides, disperse the heat and waste, and the energy comes in the fossil fuels. That's a subsidy to maintain this very concentrated city, including the incredibly concentrated cities of today. And with a much greater energy flow because we're using fossil energy. And likewise, we we subsidize our beef production with fossil energy. Pastures, I mean, they still have to eat the same, but you get much greater yields. And finally, if you look at the efficiency of going from the sun to plants to geological work to power plants and so forth, the huge loss of energy from the second law at each of these steps, ending up with the enormous amount of energy we humans take, still requires this enormous food chain producing the energy that we use. And here we are. Okay, so that's my lecture for today. I'm just going to, let's see, I ran over a little bit, so I'm just going to stay here, and anybody can take a break if you want. You can turn on your mics. Let's see, I'm going to,
So, Charlie,
yeah,
so humans have been seeking to concentrate energy to put to their uses, to human uses, through all of human history. And how was that connected to our evolution? You know, we've been really trying to grab as much energy as we can per capita.
well, first of all, let's take the long view of human history. And the long view, of any animal, plant too, I suppose. What have we been selected for? And as I used to say to my freshmen, that we've been selected to be horny and acquisitive. I'd start my evolution. I would actually just blow them out of the water, because I'd start my evolution history lecture by saying, "Oh, I feel pretty horny this morning. How many of you feel horny?" There's a class of 120 kids, and one or two guys, and I'd say, "Well, how about since yesterday this time?" A few more hands would go up, and said, "Well, how about in the last week?" And pretty soon the students are embarrassed not to hold their hand up, and you get most of the class agreeing that sometime in the last couple of weeks that they felt pretty horny. And I said, "Well, how come you feel horny?" And I'd get all kinds of answers. I'd certainly have their attention, by the way, because I probably have your attention now. And I said, "What do you call your ancestors that weren't horny?" Get a lot of interesting answers to. And I said, "Well, I'm not quite sure what to call them either, but I don't call them my ancestors." So get them to thinking about natural selection is not something that happened in the past with dinosaurs, but something that had a whole lot to do with what you were now. But I would say that our ancestors had been selected to be horny and acquisitive, and that's the root of our problem today, is that it's built into our basic genes that, until birth control at least, that we would have a lot of children and that we would have a lot of desire, because in general, men, speaking sexist for a minute here, men were properties, birds that are property in my backyard. Birds that are property are more likely to mate than birds that are, and that's why they're singing and why they're proclaiming their territories. And so, guys go around with fancy watches. I don't, but guys go around with fancy watches and fancy cars and stuff. And they're just dealing with their genes that have set them up to be this way. But is natural selection occurring now? Well, it certainly is. but to a much smaller degree. And I've thought about this in the past, and I'm thinking that our inner city kids are probably much fitter than the children of most of us, because they are still much more subjected to natural selection. Their death rate is much higher, which I do not approve of. I'm just trying to state it. So is natural selection occurring now? Of course it is. But you got to realize, to have natural selection, you have to have two things. You have to have whatever you're talking about, whatever critter you're talking about, species you're talking about, you have to have them dying and you have to have them surviving. And we have a much higher percentage surviving. I would ask my freshman classes, how many of them would be alive without modern medicine, and about a bigger half would raise their hands. So presumably without modern medicine, there would have been a lot more natural selection on those people in my classes than would otherwise be the case. So yes, natural selection is still working now. No, it is not working as powerfully, which has allowed our population to expand so much. And here we are. I don't know if that's the answer, but I think it is.
No, that's a lot of room for thought.
I don't know. Do you have kids, Paul?
Yeah, I got two boys.
And would they be alive today without modern medicine?
I think so, but
No.
under natural conditions, very few survived, right?
Well, the thing is, we don't know what the future environment's going to be.
Yeah.
And how long are you talking about? And we're gonna talk about this a little bit. It's not entirely a pleasant
30.
situation.
My youngest is 30.
Well, he's made it to reproductive age.
Yes, and he has reproduced, in fact.
Well, there you go. Your genes will survive. Yeah. I chose not to reproduce.
I know.
I was very careful. To my knowledge, I have no children. Let's have a few hands up. Cassie, you look like you might have a question.
Well, I think it's more of a comments and compliments. I really enjoyed this class today. Thank you.
Good.
I wish that you also could have spent more time on several of the subjects at hand, and more time with each of the different pictures you showed, or graphs and so forth. And it was pretty interesting.
Go back.
About the women in their long dresses working in those around the looms. And I think if we all knew how dangerous it was to work in factories back, for several hundred years, actually. So yeah, there was just a lot of great slides and presentations today, and I just wish you could have spent longer on them.
Well, we got great slides coming next week.
Well, I'll stay tuned. Same bat time, same bat channel.
I do want to say that I once read a book long time ago, 40 years ago or something, on where safety standards came from. Workers' safety standards. And the whole thing of workers' compensation, I think the book was focused on workers' compensation. because in the old days, if you were hurt in a mill, and you lost the use of an arm or whatever, you would be fired because you weren't producing. And so not only did you lose your arm, you lost your means of income. And this was the first means by which workers organized to gain rights relative to industry. And the whole history, I'm going to take a look to see if I can possibly find that book. I probably cannot. But the whole question of workers' compensation was the first big strife between labor and capital. And, all, including today, all throughout history, there have been intellectuals who have argued that the workers should be paid only enough to support them. I'm trying to think of the original economists that concept goes back to, but that the minimum wages, you should pay your worker only the minimum possible, because that would make the whole process more efficient. And this whole idea of what's called Pareto efficiency in the economy, we're going to talk about that a little bit. An awful lot of what are considered to be laws of nature are, when you track them back, very self-serving of a particular class of people. And I was even reading something yesterday about how somebody trying to understand the conflict we have now in America as a class conflict. And it's not quite classical class conflict, but it is, I'm sure that, well, Marx, for example, would have something to say about this and to trying to understand it. And it seems to be inevitable. There was enormous resentment back in Jane Austen's time. And even you can detect it here and there in her novels, a resentment of people who thought themselves better because they had more money. And there was a general sense in English society that if you were wealthy, you were somehow a better person. But she actually paints many of her wealthy people as fools. And
well, we have this same dichotomy at work today in our legislature. There's a strong resistance to raising the minimum wage in Louisiana from $7.25 an hour to something more, more in tune with the times. And we hear exactly the same arguments about you just want to pay them enough so they don't fall over in the street, but not enough that they lose all motivation to do something else, And
you look at a herd of elk or a pack of wolves, and this dominance thing is very, very much there. And never ceases, it seems. It seems I think as a biologist, as an ecologist, that we don't think enough about the social contract. That I really do think that there is improvement of the conditions of natural selection through a social contract. And the social contract is fundamentally is that you and I might both want the same woman, but we've agreed not to hit each other on the head to gain each other's, because the cost is greater than the gain. And that's the basis of the social contract, and it's extended out from there. And partly in preparation for this, I keep getting off tangents when I'm poking around and looking for the pictures of women with dresses and so forth in working in factories, that the origin of this country and what Paine's common sense, I guess Thomas Paine, whatever Paine's the early writings that led to a sense of human dignity and quality and all of this stuff. Where did this come from? And I think we have the possibility of manufacturing the society that we want. But
definitely.
Go ahead, Cassie.
Just through the communications that they put out. You hear it long enough, people start to believe it.
Well, I read a recent thing. I agree with you very much, Cassie, and it's a very but there's somebody who just lost their job today, which we can all say was because people want to hear the truth. One can say that. But I read just the New Yorker had an article about Sam Adams, who's we think of as a brewmaster, but actually was a malt maker, and not a very good one, by the way. That he how the ideas for the American Revolution came to be, and they came because people thought about it. Thomas Paine and Thomas Jefferson and Ben Franklin and so forth, because people thought about what they wanted. And I think that's still very much the case. Now, Cassie, when we get into a little further into the course, then we're going to, just as natural selection is always bumping up against limits. So as I said today, the conditions are favorable, a species expands, but they begin to overuse their resource, or the predators key in on them or whatever. And this seems to happen again and again in the natural world. And so part of the problem that we face is, what kind of society can we build with the constraints that I'm going to talk about? Very simple ones, how much oil is left and so forth. Is it possible to make a transition to solar and so forth? So I'm leaving the last session open, but I'm really nervous because you people don't ask very many questions. I never had so few questions when I've been teaching. Okay, here's another one. All right, somebody else put their hands up while you're thinking about this. Go ahead, Cassie.
So part of this could play out to AI and the use of robotics, because they're really thinking, society pretty soon will not be working. Humans won't be working as much, for sure.
Which I think will be really bad.
But yeah, we'll really get fat and sloppy.
And psychologically unmoored. I think work gives almost everybody a psychological mooring.
Yes.
Even I, about to be age 80 next week, is preparing for this class. It gives me, I'm still write papers and stuff too, but this is psychologically mooring for me. And so I think it is for other people as well. Indeed.
Yeah.
Diane, Christy, Dennis, Gloria, Bob, Terry, say something. Kathleen, raise a hand, get used to it. Help me for my last class.
We need their energy.
You're disappearing.
I think you put them on the spot.
They got stage fright.
Hi,
There's
Diane. No, here she is.
Well, I think I don't have many questions because I loved your presentation today. I loved especially about how the energy of the earth is the heat pump. I had never really understood completely all the trade winds and things. So that was fantastic. So yeah, I don't have questions because you did such a great job.
Well, thank you very much. Thank you. Are you in Ashland?
I'm in Talent now.
Talent, close enough.
Yeah. For the suburb.
Ashland, I don't know. Of Medford, I don't know. I never thought of it. I've only lived here for a year, so I don't have a good. I come from Montana. What do we know?
I lived in Ashland for 10 years and then we made the move to Talent because I get more sunshine here.
It's nice. I often think there's a little bowl of sunshine because the mountains around us all have an orographic clouds. Orographic clouds mean clouds that are generated by air masses being pushed up mountains. But we're in almost a little cloud-free zone or lower clouds. There's plenty of clouds here, but not as many.
In a rain shadow, yeah.
Mm-hmm.
Which I like.
So
Right.
you've only been here for 1 year so far?
Yes, a little more.
So you're going to have, a lot of wonderful streams and rivers to explore.
Yes. Yes. I'm doing that. Although I don't like, I miss Montana. The rivers in Montana were magnificent but yes, there's a lot of beautiful rivers here. And I like to fish, and my wife and I, we were going to go this week, but then she's got to finish her Ollie classes. So we're going to go next week. And I got some special places I want to look into a little bit to the east. So I'm looking forward to that. What would you like to hear more of? You like the heat engine, so and the trade winds, and you like the women working in dresses and all of that.
Well, I really
the mine woman looked a little more. The women working in the mines looked like they were wearing their Oshkosh by gosh pants, So they were a little more practical. I think a lot of it is a class thing, and it isn't just those women. Obviously, were not upper class in the dresses, but they wanted to be as respectable looking as possible. Mm-hmm. And I often think, since I spend very little time looking, well, I do take a shower in the mornings of my classes and put on one of my 2 good shirts. But, the people before were very conscious of looking the part and spent an enormous amount of time and energy, of course, on their clothes. And much of it is to differentiate themselves from other people. And I think America was much less class conscious, and it meant a whole lot. I mean, to me, it's been much more comfortable. But there exists in science our own snobbery system and so forth. I think it's part of human nature. I know that human nature. Every day we look at the news, my wife is depressed by the continuation of human nature. And Cassie, going back to the first thing you said, misinformation and so on. And, it'd be good if we could really get to the heart of this, because I think it's very disconcerting to me how different I view the world from other people in Oregon, and the country more generally. So I don't know. Okay, last chance for, yes, Diane.
I went several times to Romania taking medical equipment that had been no longer in use. at the
I'm sorry,
hospital.
can you get a little closer to your microphone? Yeah.
I
Okay.
think that's it. I went to Romania twice, taking medical equipment from that was no longer used at my hospital in Mountain View, California. And I didn't want to leave because there was just absolutely none of this, gee, I've got the biggest car or I make the most money. People had struggled so long and so hard there that they were really focused on helping each other. And I just loved it. I didn't want to come back to where everybody was being the one-upsmanship that we have here.
You went to where?
Romania.
Romania. Ah,
So I repaired medical equipment, so that was my job. And so it was a very rewarding thing I was able to do there.
Wow.
well, I think there are lots and lots of, that I got my eye on you. There's lots and lots of manufactured status, and I think advertisements are full of it.
Yeah.
And I guess in Romania, we can understand a lot of really nice people in Romania that are closely related to Italians, a little bit of an Italian bit to their culture. Although Italy is certainly full of glass and all of that stuff. Yeah. All I can say is yes, and I've worked in 30 different countries, and most of them are less status oriented than the United States. Yes. Ted.
That's slightly off topic, but since you mentioned it, as a Montanan, what's your view of the television series Yellowstone?
Oh, first of all,
Good
I
for
love
Montana,
dances.
bad for Montana.
I love Dances with Wolves way back, so I thought I'd like it. And then my wife and I watched about 3 of sessions, and it didn't quite ring true. And you know, we prefer the real Montana, so I guess I don't have any opinion because I haven't watched it for 2 years, so I don't know. I mean, you know, I like English television, British television,
The BBC, yeah, the sitcoms.
or whatever. I got a
All
list of
creatures,
favorites.
great and small.
Pardon me? Oh, yeah. My wife especially loves that, yeah.
Charlie, I guess one thing is you have this Dropbox with additional materials in it, and maybe at the beginning of the next lecture we could kind of get introduced to how we should use that.
Well, let me tell you the question I have. I'd love to get this lecture series available to the world. And I wonder, and I think, right, I mean, the people, not everybody likes them, but the people who like them sometimes like it a lot. So how do I do that? Okay, now what materials, Paul, do you think? Like
Well,
all
you
the
have
books I can-
materials on the Dropbox, and I have to say, I haven't really explored it carefully. But is it all
I
just?
can put my papers on there, but
Well,
they're
I'm just
kind of
saying
academic.
that if there are now, you'll mention books when you are passing through.
Yeah. Well, then I run into copyright things.
No, well, I mean, but citations is
Oh,
not.
what they are. Okay, good point. Good point.
Yeah. 'Cause,
Okay,
you know,
well, I'll have to review my slides and see what I can do.
yeah, particularly
Okay,
about
well,
the,
it's officially the end of our time.
okay.
And Cassie, I want you to keep asking questions, and you too, Diane.
Well, I just loved how you did today. It was so much information. Just really appreciated it.
Let me ask you this: should I give this again next year? And can each of you find at least one person to take it?
I think so.
Is that an idea? Should
Yeah.
I do the same class next year? Think about it.
Well, especially since many of you are in a small area, you could develop a whole strata of educated people.
Well, my wife, well, there's a lot of very educated people in Ashland because it's a university town and it's a culture-y town. They're mostly in the arts though, but which is fine with me. But my wife is looking for people to make a book club with her. Does anybody know a good book club? And another thing I'm looking for is we met two Swedish American women with a white Labrador puppy, just almost becoming a dog. And my wife said, I'd love to form a book club with them. Anybody interested in the book club? And it wouldn't be about this stuff because my wife is sick of it.
Does the dog read?
I don't think. I don't know. Never can tell in Ashland.
Oh, God. Well, at least you tell the truth.
I've heard that there are several
Gloria,
people
turn
that,
on your camera for a minute. And Kathleen, let me just say hi to you. I like seeing people. I don't know, maybe they're not.
Okay, Charlie, I've got to run, but
Yeah.
I think I did a yeoman job of admitting people. So
Hi, Kathleen.
by the
Everybody's
way,
happy
I've
to see
heard that
you.
there are several educated people in Phoenix and Talent and Medford.
Absolutely. When I say Ashland, I mean the region, yeah.
And just because they're educated doesn't mean they're smart.
True indeed.
Oh, yeah. And people are interested in, we have a lot more artsy folks in this region, I think, than sciencey folks, but I'm trying to give us a science that's a little bit artsy, so a little bit
Oh.
artsy fartsy.
no, it's
Um,
very refreshing, even for a scientist. It's refreshing. Okay.
Okay, well, remember the first book I read in college was Two Cultures, so we're doing something to kind of bring them together. Okay, well, over and out till next week, and
Bye.
I assume nobody had any problem, but there's a few less people than the one person I know is in Hawaii. So,
Well, you had, I think, 18 at the
19.
peak. So that's not bad.
well, we had been 28 at one point, so
Okay.
I don't know, but maybe people are looking at them at a more convenient time on my, on the other, do you people know each
No doubt.
other? Oh, they were just a bunch of strangers, huh? Okay,
Well, we're getting to know each other.
yeah.
Thanks, Charlie.
Thank
Thanks.
you.
Very,
Okay, bye,
very
Ted.
interesting, fascinating.
Okay, good, I think so. Bye-bye.
We'll see you next week, Charlie.
Okay.